It's a lightweight web server, pure TCL, lightweight but featureful. That has a lot of nice aspects that I like working with. I've added some access to different TCL features such as hierarchical namespaces. As far as I'm aware, TCL is the only dynamic programming tool that has hierarchical namespaces. Someone correct me on that, but I think it's an underappreciated aspect of TCL. Using the info frame command to figure out, to help manage event-based processing, and package modules to store API code. Has everyone at least looked at or familiar with the idea of package modules, opposed to just packages, where you store your package files in a file system path that reflects the name and the namespace of the package? I found that very useful too. Most of the time it's used to deliver legacy packages in a more comprehensible way. I tried to use it in a more positive way, in a different way of designing things. So this is an overview, just to show how things are structured. It's delivered as a set of TCL packages. The framework is each of them are separately developed and interact. Starts with a wrapper around, a sort of introductory wrapper around the base Wibble web server. This handles basically initializing the state, and it allows you to manage the state of each connection on a per connection basis. You have a Wibble server for handling the basics of the HTTP. Wibble has a feature known as zone handlers, which it uses to dispatch URIs to procedures which handle the URIs. It's basically a table of prefixes which map to procedures. And I have written a namespace-aware dispatcher, which basically works as a zone handler within the Wibble server. The dispatcher takes a URI and maps it to a namespace hierarchy, and can then serve the URI. And at the end are different services that's just simply meant to specify that you can create a number of separate hierarchical namespace code sets and compose them into, create custom composed collections of services for each connection. So you can specify exactly what the user needs in terms of services, and they get accessed in the appropriate way on a dynamic basis. So I'll go to the middle of that, start out in the middle of this diagram. The dispatcher I call simply package tree, in order to get an idea of how things work. The idea that I had is that a URI is simply a hierarchically structured request. You have these nice hierarchically structured namespaces. And you also have the hierarchically structured package module paths in the package module site, making use of the hierarchically structured file system. So we have the service-oriented idea of hierarchically structured services that work together to provide a specific response to a URI. So what happens is that we simply define these packages as creating namespace ensembles. The URI is resolved into a procedure name and arguments. And the nice thing is the dispatcher checks to see if the specified namespace ensemble exists. If it doesn't, it looks in the package module site for a package that will fulfill the requirement and automatically load the package and run the procedure. And this is a very simple illustration of that. If you have an incoming URI for something, document, statistics, word count, tutorial.txt, that gets resolved into a hierarchical namespace with an arbitrary prefix, API, document statistics, word count with an argument of doc, which was automatically given the correct value by the dispatcher. And if this procedure doesn't exist, then the dispatcher will look in the TCL module path, and the path name of the package module file reflects the name of the namespace, and it will load this package module and then run the expected procedure. So these are some helper procedures that the package tree package provides. For example, the provide procedure, since the name of the package and the namespace of the package can be introspected from the file that it's being called from, you don't need to specify that stuff within the file itself. So the provide procedure automatically creates the appropriate namespace and sources the code into the namespace. And that makes it handy because you can rearrange your API simply by dragging and dropping a package module file between places in your file system. And the dispatcher automatically figures out what sort of API you want to have. And the public procedure is a way of specifying which procedures you actually want available and visible on the website. And so simply a helper for creating a namespace ensemble. And the resource command is another example of trying to use composed hierarchies. The resource command assumes that you've created a separate resource directory for static files. And the resource directory, again, mirrors the URI pattern of the API that you want, so that you don't need to specify a path for any resource that you want. The resource command figures out what procedure it's been called from and automatically retrieves the desired file from the directory that it resides in. And this is a very simple example of what a very simple package module might look like. The first line would be the provide command, which simply creates the namespace, API document statistics, loads the code into the namespace. We declare a procedure called word count as public, and then we declare that another service, which has been externally defined called internal service, is going to be available. And here we want to say get a word count of a document. And so we want to make sure that we return the proper MIME type for the document. And so we have this command MIME string, which is not defined, but if the specific procedure is not found, there's a custom namespace unknown procedure, which will check the added services and load the packages that enable the services automatically. And if the desired procedure is found, it will be run. And so then we just have a very simple way of generating a word count using the resource command, which only requires a partial relative file system path in order to find the desired document. So you can specify and restrict which documents will actually be available to the ones you actually intend to be available. And initially, when I started working on this program, I thought in terms of initializing the web server with a prefix for the namespaces that will allow me to restrict which namespaces were visible, so that I would have a degree of security, and then I would be able to call the API that I wanted to with various URIs that were coming into the web server. At some point I realized, and this I used using the namespace path command and the namespace which command, which is analogous to the Unix names path environment variable, and the which command, which controls just what executables are visible to you. And at some point I realized that there's no point, you don't need to restrict yourself to simply initializing the web server with certain URI prefixes or namespace prefixes. The wrapper around the Wibble code has a getter and a setter that allows you to set and get state values on a per connection basis. And so you could simply call the namespace path command and uniquely specify a particular namespace prefix which would allow you to control on a per connection basis exactly what code is visible to the visitor. And so all you need to do is figure out a way to qualify each visitor in terms of what resources and services they deserve to have access to. And you could have a idea of transitioning from one allowed namespace to another. If you have if you're maintaining session credentials, you could simply save a namespace, a hierarchical namespace value in the session credentials. So in the next visit, the visitor would already have a preset allowed set of values, allows subset of the API that they can access, and this would allow you to, using the basic techniques of storing and retrieving session credentials, to move a visitor through your API in a way that accomplishes a specific task. And all you need then is basically you have to figure out a mechanism for validating whether or not a person a visitor is entitled to use a specific set of services and revalidating as they move through a particular workflow. And I found, sort of serendipitously, that the Wibble zone handler table is very good for that sort of thing. The zone handler table, as I said, is basically just a table of URI prefixes which map to procedure names. And the nice thing about the zone handler table is once it finds one match and runs one procedure, it just keeps going. You're not restricted to just mapping to one procedure. The zone handler table will keep matching and calling procedures until one of the procedure calls an interrupt and says, okay, we're done, return a value. And you can do more with zone handlers than simply creating and formatting content. You can do other things, anything you want, including evaluating the state of the visitor, saving and retrieving session credentials. And in that way, in the rather serendipitous interaction of the router table and the hierarchical namespace mapping, you sort of get workflow with very little extra effort. And so we have the wrapper package, which uses the info frame command in order to retrieve, figure out exactly where it's being called from at any time, so you can maintain a custom set of state for each connection. The zone handlers can not only retrieve content, but manage state in a series of pre and post calls interactions that allow you to manipulate the state and save it in any session ID, session management code that you have. And in that way, I've looked at different workflow and role-based access packages, and basically the idea that they present to you is that, well, all you have to do is litter your code with a bunch of if conditionals, and we'll set up these values. And if the visitors match the if conditionals, then they'll have access to this stuff. And that is, I think, cumbersome and easy to make mistakes. So in this way, using the namespace features of TCL, basically you can write code for satisfying URI, and the code doesn't have to have any knowledge of the policy that accesses it. That if an individual visitor doesn't have privileges to access a part of the API, that part of the API is simply invisible.
You said info frame, do you mean info coroutine?
No, I don't use coroutines because I want to maintain compatibility with older things. If you were restricted to 8.6, info coroutine would be a very good way to go, because that's a very simple way of identifying which event, where you are, what call stack, what call frame you're in. I wanted to maintain some backward compatibility, and so I used the somewhat more complicated but more general info frame command. At some point, I would like to do at load time, check whether I'm in 8.6 or something earlier, and if I found myself using 8.6, I think the info coroutine would be a much better way to go if you had that going. So the goal is, as I said, is to make designing a dynamic website roughly similar in feel to designing a TCL program. And when I design a decent-sized TCL program, I think in terms of individual packages and how they interact. And using the TCL package module feature, it's very simple. You just simply you write and name your package modules, drop them in someplace in the file system, and the web server will automatically pick that up as a live dynamic URI. And it's easy to move things around as well. And you can, in terms of, you can have a API namespace hierarchy, and you can create any number of separate independent namespace hierarchies. And the namespace path command, similar to a Unix path environment variable, takes a list of namespace names, and you can basically compose a hierarchy on the fly of allowed and valid services that you develop independently. And what we want, a design goal, is to have a high degree of confidence that you didn't slip up. As sometimes if you try to program something like an HT access file, it's easy to get paranoid that you might have made a mistake and allowed access that you didn't intend. So the idea of this design is to give yourself a high degree of confidence that you're only granting privileges that you really want to grant. And applications for this, the state-of-the-art for granting things like user accounts, role-based access management hasn't really changed in the past decade or so, as far as I can tell. And part of my goal is to make things of this sort easy and straightforward, not only managing user accounts, role-based access management. Once I've noticed that in a lot of collaboration tools on the web, you often have choice between read-only and write everywhere, and that's pretty much the way it's been for a decade or more. It'd be nice to be able to write more fine-grained collaboration tools where it's easy to manage a more sophisticated set of privileges for people to collaborate online. Workflow, as I mentioned, I think is very important, and it's easy to set up for virtual servers, multiple separate APIs. And it's basically switching between them is a matter of no more than writing a zone handler in order to assign the appropriate namespace prefix. And I figure once we have nice things like workflow management and role-based access, there's no need to restrict it to the idea of a web server. It might be possible to use it in other contexts as well, in other kinds of programs. And that's what I have today. And I think the takeaway for me is that TCL not only is surviving, but if you take a fresh look at its unique features, I think it's uniquely suited more than ever to the specific programming challenges of today. That's what I learned. Questions? We have time for questions? Okay. Thanks.
Okay, our next speaker will be Andres Bus.